Thank you, Sean. It's great to be here. Last year was a great GTC for us. We announced Octane 2. We had a really good year. And this year, when we were asked to present again, I figured I wanted to really focus on our long-term goals as a company. And a lot of that centers around what we sort of call holographic rendering. And that's why the talk today is called So You Want to Build a Holodeck. There's two ways to approach holographic rendering, and some of that actually overlaps into the real world with Lightfield captures. So we've been doing LightStage for years. In fact, it started out of ICT's graphics lab. We are still working very closely with Paul Dubevik, not just on Lightfield capture technology, which allows you to capture imagery and textures in a holographic context, but also project them. And we are going to be building Lightfield prototype displays just so we can test what that looks like at a larger scale than what we're showing here in this early prototype. There's another alternative, though, of course, to sort of approaching the problem or the solution, I would say, to getting holographic rendering to work, and that is to make it much simpler, right? And to look at it from the perspective of VR and AR. And thanks to shrinking cell phones and amazing screens, we now have devices like the Samsung Galaxy Gear VR that are coming to market and that can basically strap a cell phone to your face and give you an incredible experience. I mean, truly incredible. In fact, this year, I didn't bring a bunch of servers at our booth. I just brought a bunch of Gear VR so you can see what we're rendering on those things. It is phenomenal. And as we sort of expand our repertoire of how we approach Lightfield rendering and holographic rendering, certainly we're going to be looking at doing full Lightfield cameras. But what we're really thinking is going to be the future of this pipeline is going to be synthetic rendering. And so I'm going to basically play a 2-minute video, and I think it'll be sort of self-explanatory. And after that, I'll follow up with what we're doing in this space.
Something that OTOY did a test render for this, and they actually added a feature to their Octane renderer that builds stereo panoramas in this absolutely peak quality for Gear VR version, where it uses our cube map format for the overlay shaders, and it's perfectly sampled, perfectly set up. And those are literally the best images I have ever seen through any VR headset anywhere. They have, if you've seen some of OTOY's work, they have some, the things that show off ray tracing, semi-transparent stuff, reflections, ambient, good global illumination. And they've got some, like a kitchen scene and a bedroom scene. And I see people that will just sit there, and they're like, I could stay in this kitchen for hours just looking at how high quality the renderings are. But what's important about this is sort of our benchmark. So we can say, with this exact display, we can hit this level of fidelity that is incredibly good. So we can start approaching that with our real-time rendering and eventually be able to be doing that level of quality both for captured things in the more general form with light fields. And I should also mention that when I saw OTOY's Lightfield work, I went into it, as with so many things, the secret to happiness is reasonable expectations. I went in with, I had seen some lumographs and Lightfield work before that was generally kind of a blurry mess. It was the sort of thing where you look at this and it's like, okay, it's neat that you can rotate it around and view it from different things, and you can sort of see the future in it, but you're not actually analyzing the quality of the thing in front of you. So I was pleasantly surprised by the Lightfield demos where what I saw was just where you had like a picture window that you could look through, but it was captured, it wasn't captured, it was synthetically rendered, but you could move around that, and I was surprised by how good it looked.
So he mentioned two things, and they're actually two separate solutions that we've come up with for VR, both of which are looking incredibly promising. The first one was basically we saying this high-quality rendering that he saw in the Gear VR. That's happening inside of Octane, right? And Octane has been focused on getting real-time rendering to be the absolute best possible quality we can get. I mean, it's unbiased rendering. There's no shortcuts. We're really working towards rendering reality and not looking to go down the biased rendering route. I mean, there's definitely a lot of value maybe to that approach, but for us, it's important that we persevere. And as we get into more complex forms of rendering, as we get into light fields and this kind of the things that VR demands, we really are starting to see the justification of going really deep into not just GPU rendering, but unbiased rendering as well, because we're starting to render just crazy sets of data, and caching lighting sets when you're rendering those light fields doesn't make any sense. I mean, you're essentially generating photon maps when you're creating light fields, and that whole process probably should start with an unbiased render. So OTOY's mission is, in the long term, is pretty simple. I mean, we just want to make this holographic rendering pipeline a reality as soon as possible. And with VR and AR emerging, actually exploding so quickly, there's an enormous justification for that. And obviously getting people like John Carmack interested has been a really good incentive for us to do this even faster. So I'm going to quickly recap last year. Octane Render 2.0, big release. I promised you guys then that Octane 2 would be production ready, right? It should be able to replace a CPU renderer, and that to me was a really important turning point where we could pretty much drop CPU rendering as a requirement for doing high-end films. And I think we got there. I mean, the quality in 2.0 was absolutely amazing, and this is something that is fantastic. We also rendered this, by the way, as light fields and holograms now in VR, and it looks so much better than an image. But to get to that point, we really had to make sure Octane was an amazing 2D render, amazing film and visual effects render before we started doing these more advanced things. So we got to that point last year, but it took us about a year to finish, I would say, complete the 2.x cycle, right? We wanted to add motion blur, displacement mapping, fur, all these things that you kind of need to have if you're going to go and do a movie, and switch from CPU rendering, which has been mainstream for decades, to what we know is the future, right? And so I had a test for myself, right, that basically said that when we got through out-of-core texture rendering, which is a hard thing to do, we weren't sure that was going to work, but it did work. The last thing on our list for 2.0 was doing Oculus VR support, and as you can see, that turned out pretty well. But I had one final test, which I started 10 days ago. I went to Barcelona, and I basically went to the office of an artist I've been working with for 10 years, and he's a legend in the visual effects industry. He runs a company called BLR, and many of you may have seen his work. I mean, in fact, the guys we know at ILM say, "Oh my God, you work with JJ at BLR? Like, does he use Octane?" And I was like, "No, he's been using V-Ray for 10 years, and getting him to switch is like telling Yoda 900 years into Star Wars to switch lightsabers. It's really hard." So it was a process. I gave myself 10 days. 10 days ago, literally. I just got back from Barcelona a few days ago, and he saw Octane 1.5 a year, I guess, in 2013. So it's amazing, but it's not production ready. And he gave me the list of things, a lot of which you see in 2.0. And I was very curious to see what happened when we gave him the final version of 2.0. And other than a few driver problems, which we solved, he decided, all right, I'm going to take the most complicated scene in my most complicated short, which is Keloid. You can go to Keloid and check it out. It's absolutely mind-blowingly awesome. And he said, this is something that I have $100,000 worth of nodes that render V-Ray, not V-Ray, actually normal V-Ray, and it takes about 4 minutes a frame. So I want to see this one running in Octane. I want to see if we can fit all these things on the GPU. It turns out we need 12 gigs of memory to run in Octane, but when we got it working, it rendered in 2 minutes on 2 Titans versus, which was what, $1,000 bucks? I mean, it's versus $100,000 of CPU rendering power. He's got the largest CPU V-Ray render farm in Barcelona. And that was a really awesome moment for all of us. But the thing that was more important than just the fact that the rendering was fast was that during the setup of these scenes, and he would say it would take 3 days to set up a scene like this because he didn't have the instantaneous feedback you get within Octane. So that was the big delta and change for him. And once we got that working, once all the Keloid was running in Octane, well, then we got into the VR and holographic stuff, and that was when things got really cool. And this is just a test I captured on my cell phone. But this is what Octane renders when it's rendering a light field. This is what Carmack was talking about in the DK2. And it's hard to explain or show without you having a VR device. But it is basically a portal, and you just have this amazing effect, and it looks incredible in a VR device. And this is not something we can ignore. In fact, we're going to build a product around that, and we're going to approach it in, I think, an interesting way, differently than what we've done before. So this is Octane VR. It's basically Octane standalone, and it's an experiment. I mean, we're going to do this for 90 days. We're going to see what happens, and we want to continue it after that. But we're going to make it available to anybody on our website between April and July. It's going to have all the Octane features from 2.2, basically the final production-ready version of Octane. It is not a demo version. And it's going to be free for commercial use. You can do anything you want with it. And the reason why we're doing this is that we so strongly believe in this ecosystem around VR that we feel we need to get people to understand and be aware of it, and we want to open that wide open. And we think that with that happening, this is going to get a lot more users into Octane. And there's other services we're going to be offering above the standalone. We have cloud rendering, there's plugins. So if this works out, we may make the standalone free. It's a first step into that direction, but Octane VR has a purpose. It is not just a free version of Octane. It's to get people to start creating the things that you should go to our booth and see it, that Carmack's raving about. I mean, it is an incredible delta from anything that we've ever seen. I mean, it's like going from black and white to color or silent to sound. It's that kind of extra dimension for cinema that I think deserves its own attention and focus. But that being said, none of this works without us solving every other problem in the rendering pipeline, the traditional rendering pipeline. And if you looked at that holographic rendering test we did for Keloid, you can't do that in 2.0, and we're not going to add it to 2.0. That requires pretty much a lot more work in Octane, and we're done with 2.0. So we want to make sure that's a production-ready, stable render. So that basically means we need to do a new version of Octane, and I want to introduce you to Octane 3, which is a huge step up from what we had before. I mean, I guess when we were looking at 2, we did succeed, I think, in making it a production-ready render. To me, the BLR test was an important touchstone for that. With 3, we want to have a mature render. I mean, there's renders that have been used for decades, and there's a lot of features in those things that are little things, but they matter and they add up. And with Octane 3, we wanted all of that in there. And we also wanted to break the whole render so we could add major new features that we just couldn't do last year, and we shouldn't have done last year. I think we have a solid product, but with Octane 3, we're going to do a lot of crazy stuff. So the first thing, and I think a lot of users probably will expect this, is we're going to add full volumetric supports. It's a native primitive type in Octane, so again, cloud rendering literally is easy. And it's very powerful, and it's very fast. And along with that, we've opened the door to a whole other type of rendering, right? I mean, there's primitive types that are now, other than than polygons and points and fur, that is possible now with this kind of system. And it opens the door, for example, to snow, to mist, gas, organic materials. Fractal displacement is something we've never seen in any other renderer. It's something that we created, basically whole cloth. And it's amazing. I mean, it gives you these very fast renders. This is one polygon, and you have basically unlimited detail. And things that are organic become super simple to render. And these are just examples of what you can do with that. I mean, things that are like this kind of organic shape is simple. The other thing that we knew we had to do is basically get full support for particles. And the way we want to do that is through OpenVDB support. That is now native in Octane, just like Olympic is. That's a huge feature. And basically, OpenVDB means that you can create simulations in other programs and bring them in to Octane 3. This is huge. And we have this working in Brigade. So Brigade is our sandbox for testing a lot of features before we bring them into Octane, which is the more mature product. Open shader language, right? This is in Arnold. It's out there. But I haven't seen it really well applied in a GPU rendering context because it's tough to do. But we have a working Brigade, and the speed is the same. And just like out-of-core rendering, we think it's going to work in Octane exactly that way. And we've done some tests, and it looks really good. So with open shader language, you can create your own primitives, materials, reflectance, BRDFs. It's all there. And it's very powerful. And it really makes Octane, it puts it in a whole other class. And it also unlocks something that's been a problem for 4 years, which is Octane's built-in procedurals were just our own. And now you can create anything and apply things from the Blender open shader community to this. But getting to work in the GPU is awesome. The other thing that we're going to be doing is expanding the devices we support to include OpenCL. So with Octane 3, because we changed everything, we broke and rewrote everything, we basically now have an intermediate layer. So we don't compile directly to CUDA. We compile to an intermediate format, same with Brigade, and that can target CUDA, OpenCL. With OpenCL, it's not one of the reasons why we're doing this is that we don't want to think too much more about how to do out-of-core geometry rendering. We can use the OpenCL pipeline on a CPU to basically solve that problem. It's also going to be a free version of Octane 3 that you can use anywhere on a notebook that doesn't have a GPU, for example, and therefore your Octane licenses can then be applied towards GPUs on an appliance or in the cloud. We also are adding support for FBX because the Limbic data set is just too heavy. PTEX support is also being added. And from here on, there's just a litany of huge features. Probably just best to go through them, and if there's questions, we can go through that in the Q&A. Deep pixel rendering, another major feature that we've been working on for a while. There's now a live bridge, so you can actually run Octane in Max and in real time change the scene and see it in Nuke. We're building our own Photoshop plugin from scratch. It's going to ship for free with Octane, and it's going to bring deep pixel rendering, live deep pixel updating into Photoshop. That is huge. The reason we also held back our Unreal plugin, and we're also doing a Unity plugin, was that we wanted to get texture baking working and build a whole system around that. And it's a big feature. And it basically can replace light mask in UE4. It can do texture baking for any engine. But one of the things we thought we should do was get it working independently of these things. So you can actually now create and bake a scene into a media file that can be played back on the web in VR without any other engine. It's very simple. And the other thing that we fixed, unlimited mesh sizes and primitive counts. There's an infinite amount of detail and polygons you can throw at Octane 3. Raw lighting and albedo passes, another production feature that was a small thing, but we needed to add that. A lot of users asked for controlling reflections. It was hard to do that without breaking the physically correct nature of Octane, but we did it. And in the standalone, there'll be fully configurable UI, gizmos to move objects around, and you can dock and undock windows. We're also expanding the Lua scripting nodes and API to support native plugins and LLVM portable code as well. So beyond just the core rendering features, we're creating a new media file format. And the reason why we're doing that, just similar to how we did with Urbach's scene files, which basically expand upon Alembic and cover things that just aren't in those industry standard formats. This is designed to cover output from Octane. And if we depended solely on, for example, EXRs, multi-layer EXRs, those don't open in Photoshop. I mean, you just get a black screen. So we knew we had to do something to fix that, and we created a file format around that exports from Octane that, it can include EXRs, but it handles all the compositing pieces. It handles caching of render data. You can now pause and resume renders, which is a huge feature that a lot of people ask for. And it adds things like movies as textures. You can now have per node timelines in Octane. And more importantly, this is how we're going to introduce Lightfield rendering in Octane. I mean, basically now you can take a render target, convert it to a Lightfield, and even bring it back, assign it to something like a portal texture, and you've got something pretty special. You have a holographic texture at that point. And there's some really cool stuff that we're doing. We're open sourcing this file format, and it will play back in a browser. We're obviously going to be targeting the Gear VR. We're also looking at the Microsoft HoloLens. No reason we can't run on all those things. And I think that it's probably too much to get into, but there's going to be a whole set of interactive features with the scripting nodes that allow you to create full-on, published content. And so we're testing that with Warner Brothers. We're actually building this Batcave experience that's a full thing that we're pushing out of the Gear VR, and it's built all in Octane, and it's all using this new file format. So timeline pricing, we're basically going to do this differently than we did with Octane 2. It's going to be very transparent. So the alpha, we're not going to have a closed beta. We're going to give it to everybody that's an existing 2.x customer as soon as we're in alpha state, which will be probably around June. And the final release will be sometime later this year. It could be in late summer. It could be in Q3. It depends. It depends how if we nail all these features and there's no issues, then it'll probably be in summer. But you look at the list of these features, and it's a lot of work. So it's like a 15 to 16-month timeline. We're going to be working on this stuff into 2016. But a lot of the earlier features, the big ones that we showed in the 3.0 slides, those will be coming hopefully in the summer. Plugins, again, we have 21 plugins and growing, and we're adding ZBrush. Where at this point, we're also looking to get other developers to take on the Octane SDK and really build new things around it. Houdini is almost out of beta. We are pretty far along with After Effects. Motion Builder's almost out of beta and works really nicely. And then we had developers who've come to us and said, can we do a Bryce plugin? Sure. Hexagon, same thing. Paul Canadian, one of our top developers, is looking at Fusion 360. Unity is really just going to be a very similar integration to what we're doing with Unreal, and it's going to focus a lot on how we handle texture baking, which is super useful for game engines. We've talked about the cloud service for 2 years now, and we had to wait till Octane 3 was ready for a number of reasons. I think one of the things that really is key is pausing and resuming renders. If we didn't have that, the cloud service wouldn't be economically where we wanted it to be. But we're splitting this in 2 different segments, right? Both of them will be web-based. So if you go to org.otoy.com, and some of our users are actually on the service, and they've been beta testing it, and they love it. It allows you to upload a scene, and it's amazing for anything that takes a lot of time, even in Octane, right? If you have a ton of animation work or you're rendering light fields, this is the service for you, and it's inexpensive. We're keeping it free for at least the next 3 or 4 months. But we're targeting something that could be really an order of magnitude cheaper than building your own render farm. We have a second version of the cloud service that is on desktop.otoy.com, and that is where you can actually run and author apps with Octane and anything we run on XIO, so that if you want to do it all in a browser, it's possible. So I want to show you guys a video of Orc, the Octane Render Cloud Service, and how it operates. So here's basically, it's a very simple interface, but it is very powerful. You upload your Urbach scenes, export it from any of the plugins. You basically set your render target settings, and here's an animation being filled in from the cloud. This is all running on Amazon, but we are also supporting our own racks in LA. We've just built enough GPUs where it's interesting to do that. And this is pretty cool. I mean, we can set hundreds or potentially even thousands of GPUs, and you can pay for what you want. It depends on how many frames of animation you want, not just how fast you want one frame to render. So when we're dealing with these massive spatial data sets for light fields or big animations, this is going to be awesome. And the last thing that I want to touch on the cloud service, and this is an interesting capstone to the ecosystem that we're building is we talked a lot about Orbex being an interchange format. And many of you have been asking about Brigade. So the reason why that was something that we wanted to wait on was because we wanted Brigade to be able to load Orbex scenes right from Octane and really wait until it matured to where it is with Octane 3. And now both Brigade and Octane can basically use OpenSL materials, so that open shader material. So that means that they basically now have the same material system. And Brigade is going to find its primary use as a cloud service. We've been saying this for a while. It's great on 4 GPUs, but it is insane when you have a half a rack and you can do anything you want dynamically with no noise. Like that's running. It's expensive. I mean, it's half a rack, but that's something that is useful to a lot of high-end customers and potentially game developers. I mean, the budgets for games are insane. So if you're doing a shared virtual world and you want to have unbiased path tracing live, it's fully dynamic where things can explode, you have the same control you have in DX, here you go. And this is something that is nascent. We've been working on getting this going on Amazon. It's going to be part of the Octane Render Cloud service, and I guess it'll probably be something that we'll expose to as a beta to existing users of the cloud service later this year. So I think that covers a lot of what we wanted to touch on. I'm sure there are probably some questions. I think if there's anyone that wants to ask anything, I'm happy to answer or field any questions you guys may have.